Okay, so hello everyone. Today we will be solving LeetCode's POTD, which is count number of substrings containing every vowel and k consonants too. Okay, so as you can see, the question number is 3306, right? Okay, so it is marked as a medium one. Now let's just try to see what the problem is all about and try to solve it. Okay, so yeah. So you are given a string word and a non-negative integer k. Okay. Return the total number of substrings of word that contain every vowel a, e, I, o, u at least once and exactly k consonants. Okay. So here what's happening that we are given a string and we need to return the number of substrings in which there are at least all the at least I mean there should be all the vowels present, doesn't matter how many times, and the number of consonants should be present for k times, like should be equal to k times, like the number of consonants. Okay, so yeah, as you can see, this is the first example. uh, Output is 0 because here, as you can see, there are no there isn't a substring or a string in which all the vowels are present, because the vowels are a, like a is here, e is here, I is also here, and there is o, but there isn't u, so the string can't be formed, right? So there is no substring with every vowel, right? And this case, as you can see, here is a substring which is the string which is a, e, I, o, u. Okay, and the k is 0. K is 0 means that there should be 0 consonants in it, right? So how many string can be formed with this a, e, I, o, u with 0 consonant? 1, right? Now here comes the good one, right? Okay, so this is the string, the consonant should be equal to 1. Okay, so as you can see, in this we have a, e, I, o, u, and q, which is one consonant, right? Which is 0 to 5. 0 to 5 means 0, 1, 2, 3, 4, 5, right? This one, this one. Okay, then what do we have? We have 6 to 11. In this, we have q, a, e, I, o, u, right? Okay. 6 to 11. What is 6 to 11? 6 to q, a, e, I, o, u. This one, right? Okay. Then we have, like we have I, A, O, U, Q. Okay. This one. So this one is right here. Okay, so here are all the substrate. Okay, so now see, one is a brute force approach, right? There is a brute force approach, brute force, in which you can just try all substring, right? In which you can try out all the substrings, but we are not doing that here because it is easy and you may try it, but as you can see, the constraints, it's very high, I would say. Okay, so that solution will definitely not work, and as you can see, the question is good, right? The acceptance rate is also quite low. Okay, so the question is good. Okay, so let me just get to the solution part, right? How we are going to solve So let me just okay, so let's just say for this example k is equal to 2, right? And the constraints you and the problem statement, okay. So this is a problem of sliding window, I would say, a bit modified one, but let's see how we are going to solve it. Okay, so starting I will be here, right? And Jvis will also be here. Okay, so here now we are not fulfilling the condition, right? Okay, because uh, okay, so let me just also tell you that green means vowel. Okay, green means vowel. I have marked it, okay, so that the try run would be easy. It's vowel. Okay, it's vowel, right? Okay, so initially the condition isn't fulfilling, so we move the j, right? Okay, so the j is moved, j comes here. Now we have consonant as, let me just, consonant is equal to 1, right? Q is a consonant. Okay. And we have only have in this, like in this window, we only have one vowel. Okay, so we move the j, right? Let me just move it downwards. Okay, so the I will be moving up. Just so j will move forward, right? Okay, so j comes here and it's cancelled out. So here it comes like the consonant is 1 and vowels are 2, like I and E. Okay, so we move it. Again, we find a vowel. Okay, consonant is still 1 because condition isn't fulfilling, right? Okay. Then J comes here and still we have I, E, A, O. Okay, U is still missing. Okay, so here we get a U, but still this consonant condition isn't fulfilling, right? Okay, so when we come here, okay, see what happens in this window. In this window, okay, we have exactly 2 consonants, right? Let me just update it now. Okay, because we have the condition is fulfilling, right? Okay, okay, let me just write it. Here we have 2 consonants, right? Here we have 2 consonants. Okay, and we have what we would say the vowel, right? It's we have all the vowels. So suppose we have a count as answer. Okay, okay, so in this condition, yeah, it's fulfilling, so we do +1. Okay, we found our window. Okay, so now we do and so now what do? We just move it, right? Okay, so we move the I. Okay, let's suppose we just move the I. I will be moved, the condition is false, like because in this window, in this window I isn't there, right? So what do? We move the J, right? So in this window, see again, the condition is fulfilling, right? Okay. So what do we do in this case? Right? The condition is fulfilling. So what do we do? We just improve the, we just increase the count. Okay. So we have the answer as 2. Okay. So in this approach, did we miss out something? Hmm, let me just see. Okay, I think we did. We did miss a window, which, like, we did missed this window. Let me just drop it. We did miss the entire window. How? See, in this window, we have exactly two consonants and we have all the vowels. So we did miss out one, right? So the count should have been 3, but we got the answer as 2, which is wrong, right? The correct answer should be 3. So why did this happen? Because in this, when we got the first window, okay, after getting this window, we moved it like, okay, let me just clear it all once and then we will be starting with the new approach. Okay, new approach isn't that much of new, but yeah, let me just erase it and then we will be moving the actual approach, I would say. Okay. G, for G will be vowel, agree will be vowel, so let me just E, O, and I. So when we were here, like I was here and J was here, okay, we were considering this window, but we could have also considered this one, right, which we missed. Let me just draw it for you. Okay, this one, like the entire one. Okay. So how can we do it? Okay, this one was missing like it. Okay, this one was missing. Okay, so can we say that how till till which index this condition will be true? Until and unless we found another consonant. Okay, so what do I mean by it? Like suppose if here was a D. Okay, in this string there was a D at index, like suppose 8. Okay, so till here, like till here, the condition would have been true. So we would have done count is equal to D का क्या है? D, what's the index of D? It's 8 minus 6, which we would have got 2, right? Okay, so why I'm saying this? Okay, let me just show. Let me just erase it. Wait, just a second. Okay. So yeah, yeah. So this would have also been a window, right? This would have also been a window. Okay. So, which means that if we know when is the next consonant, we can find the count. Oh, right, right. Okay. So, we just need to find at what index the next consonant is. Okay. So, in this case, let me just write it down. Right. I am writing it with red. Okay. So, for this, there is no consonant, right? So, can we write it 8 here? Right, and here also it will be 8, but for this u it will be 6 because q is there, and for this here will be 6, and this for his there will be 6 because there is no other consonant. Okay, for this case also, right, and for this also, and for this it will be 1, right? So once we like get our answer, we can just check like how long will it be valid? Like at what index it will be valid, and then we can find our answer. Right? So this is the intuition behind it. Now let me just get you through the code, and then the things will be more clear to you. Right? Suppose, yeah. So like like when we come here, like the next is 8, right, at the valid, and the 8 minus 6, it's what, 2. Okay, so when we come to like what was the another window, like when I was here, right, I was here and J was something like here. So J is at 7, J is at S, J sub CC. The next is at 8, and where is J? J is currently at 7. So how many windows can be formed? 1, right? So 2 plus 1, what it will be? Like if we add these two, our answer will be 3, right? So this is what we are doing. Like, okay, are you getting my point? Because see, here it's ending, right? Here it is ending. So there is no one. Okay. So yeah, that was the intuition. Now let me just uh, go through go through the code once, and the things will be clear. Okay. So this is to check if it's a vowel or not, because if a CH is A, E, I, O, U, if any of these will be true, the condition will be written true. So, okay, so we can use this function to check if it's a vowel or not. Okay. Here we are calculating the next, like when the next consonant is. We have seen it, right? So here we are calculating it, right? Because suppose if last is equal to -1, because it means that we haven't seen the last, right? So it will be the initially it will all be having the values of n, and when if it's not equal to -1, then means we have a value. And when we are setting up the vowel, like the last one, when it's a consonant which is false or vowel, like if we get a false, then what does it mean? That it means that it's a consonant. Okay, so then we are setting up the last, right? Okay. So here is the map for calculating the occurrences of like how many times a vowel has occurred, right? Okay. So this is a counter which will, when p equal to k, we will be performing operations, right? This will, then this one is our answer. We have I and J. So suppose the word is ch, if it's a vowel, we will add it to a map. And else if it's a consonant, we will do the count plus plus. Okay. So suppose if count is greater than k, then what do we do? We are like here, new character. If new character is like, we are shrinking the window, so we shrink from the I, right? So if it's a vowel, we reduce it MP of new ch, right? Okay. So if it's less than or equal to 0, it means that it's not like we have crossed it, right? Okay, so we can just erase it from the map, right? Okay. Else we do the count minus minus, right? Okay, and we're doing the minus plus. Now here comes the part. If map of size is equal to 5 and count is equal to k, so what does it mean? That map has 5 elements in it, like it has 5 vowels, and the count is equal to k. Okay, so in this case, what we were doing, we were doing answer is equal to answer plus next of g, like the next occurrence of the consonant minus the current position, right? So this is what we have done, and we have calculated a new character, and we are again shrinking because, like, suppose where it is. Let me just, okay. So in this case, when we have found this, we were shrinking, right? At this point, we were shrinking, like we moved I, right? So that's what we are doing here. Okay, yeah. So that's what we are doing here. Till any of this condition is false, right? Okay. So at last, like we are just increasing the j. At last, what we are doing, we are just returning the answer, right? Okay. So as you can see, the code is running fine. Actually, it was, yeah, so it's running fine. Okay. So yeah, this was the solution for this problem, and it's a bit, I would say, a good one or hard one. Okay, so it's hard to get because it was also like a bit, I would say, a bit tough for me also. So yeah, once you do the try run, you will get it. Okay, it's not that hard, but it's more kind of an intuitive one. So you need to do it like by yourself to get it right. Okay, so yeah, let me just so let me just give a brief of it, right? Okay. So what we were doing, because I don't think that it's it will be like so much clear, because see, this window, we have this window, right? Okay, we were missing out this one, the bigger one, right? We were missing out the bigger one. So what we did, like suppose if there was a, suppose D C here, like okay, this will be like 8 or 9 something. So how long will this be valid? Till like before it now. So we were doing just that. We were doing the same thing. Okay. Just get it. Okay. Do the try run and you will get it. Okay. So yeah, thank you everyone. That's all for this question. Have a nice day ahead.